Hello guys, in this video we are dealing with the subject thermodynamics. This is the subject of your thermal engineering portion which we are going to study. In thermal engineering portion there are different subjects like heat transfer, refrigeration and air conditioning, IC engine and your power plant. The basic of all of that is your thermodynamics. Next, all the other subjects are the application part of your thermodynamics. So I am covering the basic of thermodynamics first, then we'll go to the application part of the thermal engineering. Now first of all, what is the meaning of this thermodynamics? As the name suggests, this is made up of two letters. One is your thermo, another one is your dynamics. So thermo means your heat, energy, dynamics means which is in motion. So as the name suggests, that thermodynamics means the motion of energy, how the energy is moving from one system to another system, from one process to another process, how the energy is moving in a cycle. So we need to study in thermodynamics. Thermodynamics deals with the energy transfer. Energy transfer means the motion of energy from one point to another point and its effect on the system. How it affects the system. If I say if energy is going out from one body to another body, then from the energy which is coming out from one body, that body's temperature will be decreased, and if heat is going to another body, its temperature will increase. So this thermodynamics will suggest its effect if the energy is transferred, if the heat is transferred or the work is transferred, then how it will affect our system. That is the dealing with your thermodynamics. Now there is two subjects in your thermal engineering. One is your thermodynamics and one is your heat transfer. Now if you say what is the difference between thermodynamics and heat transfer, first of all let me clear this. Thermodynamics will tell you the amount of energy which is transferred from one system to another system. If I say, if I have a cup of water which is at 100 degrees Celsius and after one point of time its temperature will decrease to 10 degrees Celsius. So this thermodynamics will tell me that from 100 degrees Celsius to 10 degrees Celsius how much energy will be coming out from the water, from that system. So this is a thermodynamics which only deal with the quantity, that how much energy will transfer. But rather than the heat transfer tell us that how much time it will take to decrease the temperature of that water from 100 degrees Celsius to 10 degrees Celsius. So in heat transfer we are more concerned about the rate of heat transfer, whereas in your thermodynamics we are not dealing with the rate of heat transfer. Means at what time, how much time it will take to transfer that heat, how much time it will take to transfer that work from one point to another point. So in thermodynamics we are only dealing with the equilibrium condition. Equilibrium condition we'll talk it on later on. What is the meaning of this equilibrium states? Just from the basics, in thermodynamics we are only dealing with the how much quantity of heat or work will be transferring from one system to another, and in heat transfer we are more concerned about the rate of heat transfer, how much time it will take, right? So this is the difference between thermodynamics and heat transfer. In thermodynamics there is no discussion about the time taken for the work to be done for the one process to another process. If I say if a stone is coming from some height to ground, so how much time it will take, we are not talking in thermodynamics. That will discuss in our heat transfer. That time, how much time, if there is any discussion about time, that is in heat transfer. In thermodynamics, so if that stone is coming from height to the ground, how much energy, how much work it lose or how much work it gain, how much kinetic energy, potential energy. So these are the things which are dealing with in thermodynamics. Now let us start with the basics terminology of thermodynamics. So first in thermodynamics we have to understand what is the meaning of system. As we know that thermodynamics is that branch of science which deals with the energy transfer and its effect on your system. This system, what is the meaning of this system? So system is that any space on which our study is focused. If there is if there is a pipeline in which some gas is going or some water is flowing, so we have to take that what is the system, which space we have to see, that what is happening on that part, if energy is transferring, if work is doing, what is happening with that, only that space, though that space is known as system. Next is surroundings. Surrounding is any other region, any other space outside the system is your surrounding. So if I say, if this is a example, if this is a container, or if this is any nozzle, you can say. So if this is a nozzle, and suppose from here some gas is coming in and from this point gas is coming out, right? So this is a nozzle, or some converging portion is there. So from here gas is coming in and here gas goes out. So I am only dealing with, if I say I am interested in doing my study, my thermodynamic study only with this region, with this dotted line region. If my study is only focused on this part, what happens here and here, I don't want to focus my study other than this region. So this region at which my study is focused, this is known as system. Any other portion outside this system, that complete outside this system, everything is surrounding, right? So you just understand the system. System can be anything. I can take in this, if I take, suppose I am only dealing with this much area, only this much area I am dealing with. So other than this area, outside it, that all the other thing will be surrounding for me, right? So system will be defined by you. The system will be defined by us. We can take any system, right, on which we have to focus, we have to solve the things for thermodynamics. So system will be defined by us. You can take any system, and once you defined this system, other than this, outside this system, everything is surrounding. So just these are the two things, system and surrounding. And if I add that surrounding and this system, this will make a universe. So this system and surrounding will make a universe. If I add this system and this complete surrounding, every other thing outside this much, this system is your surrounding. System plus surrounding is a universe. So this is the basic terminologies. What is system? What is surrounding? Now the system and surrounding, if I say, if this is the case, this is system, red dotted line is your system. Other than this, outside is a surrounding. So system and surrounding are divided with the help of these dotted lines. So you have to mention that these dotted lines, the area inside this dotted line is my system. So these dotted lines are known as your boundaries, right? Boundary is which separates system and surrounding, right? You define a system with the help of these dotted lines. These dotted lines are known as your boundaries. So these boundaries may be real or imaginary. These boundaries may exist in the system or may not exist in the system. You can imagine it, you can hypothetically create some boundaries in it, or these boundaries may be fixed or it may be moving, right? Boundaries may move while the process is going on. Boundaries may move. Suppose if I take this as a piston cylinder arrangement as an example of to show what is the meaning of fixed and moving boundaries. As we know, this is your piston, this is your cylinder, this is a piston cylinder arrangement. Piston is going this to and fro motion. During the process, this piston will do this kind of motion. So if I am saying, if my study is focused inside the cylinder, only what is happening to the gases, what is happening, if I say this is some IC engine, some petrol engine, some diesel engine. So what is happening with this petrol or diesel or any air which is trapped inside this cylinder, what is happening with it? If my study is focused only this, so I am taking this red dotted line as my boundaries, or this is my system. Other than this red dotted line, outside it, everything is surrounding. So in this, if I say these are the cylinder walls, this and this, these are the cylinder walls and this is your piston. So these three boundaries, this one and this one, these three boundaries are fixed boundaries. They are not moving, right? These are fixed with the cylinder walls. So these boundaries are fixed boundaries. But this boundary which is fixed with which is just in touch with this piston, as the piston is moving like this, the piston is moving like this, so this boundary is moving like this. In the compression process, when piston is going towards this direction, the boundaries will be moving like this, and if the piston is going back, so the boundary is moving in this direction. So this is the example of your fixed boundaries and moving boundaries. Boundary may be fixed or may be moving. Now boundary may be real or may be imaginary. Suppose this is a nozzle, again we are taking the example of a nozzle or any pipeline, you can say. This is a converging pipeline, area is decreasing. If I am saying fluid is going from this direction to this direction, in and out, fluid is flowing in it, there is a pipeline. I am saying, I am defining my system with this help of this dotted lines. I am saying I am only concerned about this space of the system. Only concerned about this space of the system. What is happening here and what is happening here, I am not interested in. So I am saying the boundaries which are coincides with the walls of your pipeline. These are the walls of your pipeline. So these boundaries are real boundaries. These are existing in the system. So these boundaries are real boundaries. Other than that, these two boundaries which we define just to focus our study on this part. On this part, to focus our study, we defined these two lines. We make these two lines hypothetically, or you can say imaginary. So these two boundaries are imaginary boundaries. You created it. It is not in the system. It is not present with your pipeline. Pipeline walls are these walls. So these boundaries are your real boundaries, and these two boundaries are your imaginary boundaries. So if I say in thermodynamics, we are saying this is a control volume. This is a control volume over which our study is controlled. This is a control volume. So this is a real boundary and imaginary boundary. So these are some of the basic terminology of your thermodynamics. Now, our next topic of discussion is, we studied what is system, what is surrounding, what is the boundaries which separate system from the surrounding, what are the various types of boundaries, that is your flexible, moving, maybe rigid or maybe imaginary. So the next terminology which we are going to study is, what are the different types of system that are existing. Right, we want to know what are the different types of system. Now first one is your closed system. There are three types of system which is in the thermodynamics. First one is your closed system, second one is your open system, and third one is your isolated system. Now first of all, what is the closed system? Closed system, as the name suggests, closed system means there is no mass transfer. That means no mass can enter into the system, no mass can go out of the system. Only energy transfer will take place. Those systems in which there is no mass transfer, that is, no mass is coming in the system, no mass is coming out of the system, so only energy transfer can take place. Those systems are known as your closed system. So in closed system, the mass of the system, the net mass of the system will not change. And also we can say, in a closed system, identity of that mass which is present inside the system will not change. What is the meaning of that identity of mass will not change? We'll discuss later on. So closed system are those systems in which there is no mass transfer, only energy. In thermodynamics, energy is of two parts, that is, either it is heat or work. So in closed system, either heat can transfer into the system or out of the system, or you can say in thermodynamics, work is transferred in the system or work is done by the system. So closed system means no mass transfer, only energy transfer can take place. For example, if we have this piston cylinder arrangement without valves, there are no outlet and inlet valves, only a piston cylinder arrangement is there. This is a cylinder, this is a piston. So if I am saying that I am only concerned about this red dotted lines, if I am saying this red dotted line or this area inside the cylinder is my system, right? So if the piston is moving in this direction, like this, if the piston is moving, there is no mass going out of the system, right? Because there is no valves, so mass is not going out of the system, no air or no fluid can enter into the system, only this energy transfer can take place. So this is an example of your closed system. Suppose if I am taking this kind of arrangement, suppose this is a converging passage and fluid is entering from this point and fluid goes out of the system from here, right? If I am taking that m.1 is the mass flow rate at inlet. If I am saying this is your inlet and this is your outlet, so m.1 is the mass flow rate at inlet and m.2 is the mass flow rate out at the outlet. So m dot 1 is the mass coming inside the system, m dot 2 is the mass going out of the system. And if I am assuming that if both this m dot 1 and m dot 2 is equal, which means the amount of mass which is coming in the system is equal to the amount of mass which is going out of the system. So net mass of this control volume, I make this is system with this red dotted line. So the net mass at any point of time inside this system will be 0, right? There is no change of mass, because if I am saying that the amount of mass which is coming in the system and amount of mass which is going out of the system, if these both are equal, then the mass flow rate or change of mass of this control volume will be 0. So this is that m dot CV represent the rate of change of mass of a control volume. Control volume mass will not change at any point. So we are saying that if there is no change of the mass of the system, but in this case identity of mass is changing. Suppose this is if I am taking a general example, suppose in a class there is a 10 student and one student goes out of the system, out of the class, and another one student come in the class. So the net student in the class is 10, right? If say some name, if I am saying if some Suresh is going out and if Mohan is coming in the system, net students in this class will be 10 only, but identity of the people are changing because Suresh is going out and Mohan is coming in, so the identity of the mass will change. So it is not a closed system. In closed system, identity of mass should not change. If I am saying in this case, when the mass is coming in the system with mass flow rate at m dot 1, suppose here the pressure with this, that P1 is the pressure at which this mass is coming inside the system. Suppose its density is ρ1, its temperature is T1. So these are the properties of this inlet. At the inlet, these are the state of the system. These are the property: pressure, density, temperature. So this mass is coming with pressure P1, temperature T1, and let us say when the mass is going out of the system, suppose its pressure changes to P2, density changes to ρ2, and temperature changes to T2. So this mass is coming in with this identity, this mass is going out with this identity. So the identity of the mass changes, net change of mass of this control volume will be 0, but identity of mass change, and if the identity of mass change, then we can say it is not a closed system. So for closed system, no energy transfer, for a closed system there is no mass transfer, only energy transfer, and also there should not be any change in the identity of the mass which is present in the closed system. Next example we are taking is your second type of system is your open system. In open system, both mass and energy transfer can take place. Mass can go out in the system, mass can also goes out the system, also comes in the system, and both energy and mass can transfer. Suppose for example, if I am saying piston cylinder arrangement with valves, there are inlet and outlet valve. This is your inlet valve, mass is coming in this direction, and this is outlet valves, mass is going out in this direction. When the piston is moving forward, this gas will goes out. When the piston is moving backward, from here mass will come inside the system. So I am saying that mass is transferring, mass goes out, mass comes in the system, and also this energy transfer also takes place. So this is a case of your open system. In open system, both mass and energy can take place. Energy transfer can take place. Next is your third one is your isolated system. Isolated systems are those systems in which there is no mass and no energy transfer. So isolated system means no mass transfer can take place, no energy transfer can take place. For example, if I am saying your thermostats, or you can say insulated flask. If I put a coffee in an insulated flask which is completely insulated, so energy is not transferring, that means the temperature of coffee will not reduce, or there is no mass transfer. So this type of system is known as insulated system. And the best example for your isolated system is your universe. Universe, as we studied earlier, universe is your system plus surrounding. System plus surrounding. So if I am saying, if this is my system, suppose if I am drawing hypothetically that if this is a system and other than that there is a surrounding, so in isolated system, this complete isolated system, there is no energy and no mass transfer can takes place. So there are three types of system: closed system, open system and isolated system.